know what is the percentile, what is the shading to the left. What am I going to do?
Normal.
Norm, because it's normal to find the shading, it's normal to throw shade. So where did I start? Where did my shade start? Negative 9999. Where did my shade end? 1475. So if I don't know why I threw it this far down, let me cut. And y'all, percentile is usually always a whole number. And when we're doing percentile, we always round it, we just usually drop the decimal off. So I did negative 9999 to 1475. That was my shade begins, my shade ends, my mean and my standard deviation. And when I do percentile, it's the whole, you whoop it to turn it into a percent. And we usually drop this off. So even if it was 96.75, we would still say that's within the 96 percentile. Because it's always a whole number. Alright, let me bring this one up and we can just talk about this one as well. Because now they're getting to be, this book rounds up. This is the first book I've seen rounded up. Never mind about most books usually say all the way to the whole number is the same, but this book is rounding up. So for this one, we are doing the 1262 and the 118, and our data point is 1050, and we are doing percentile. Percentile means shade below. So we are doing the shade below, and we want to know what the shade below is. So we're doing normal CDF, the negative 999 to the 1050, 1262, mean standard deviation. This book must do rounding up. I've never seen a book do that, but this book does rounding up. So you are going to round up and use the rules of rounding. So this will be the 4th percentile. We good? We've done those to death. Alright, let's try let's look at part D. The length of human pregnancies are approximately normally distributed with a mean of 266 and a standard deviation of 16. What is the probability that a randomly selected pregnancy lasts more than 280 days? Bless their soul. You going in for a long-term pregnancy. Let me check my answer. 41D. Yes. Yes. That's right. Yes. 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 Hmm. Hmm. All right. Oh. We have a normal distribution. Our mean is 266. Our standard deviation is 16. More than 280. So if this is 280, we are shading more than 280. It says, what is the probability? That means we're trying to find the shade. So this is what we're looking for. That means we're doing a normal CDF. Where does it begin? 280. Where does it end? 99999. What is my mean? 266. What is my standard deviation? Oh, help me, Lord, have mercy. I don't know why I have it so far down, but we will find it in just a second. There we go. We cut it and bring it to the top. It should have been 0.1908. So 19.8%, 0.1908. All right, try the next one. Mean is 266, standard deviation is 16. Mean is 266, standard deviation is 16. Much better. Whoop, whoop. Yay. Yes. Good. You demand. Yes. So we have a normal distribution of pregnancies, and this is saying that the average woman's pregnancy is 266 days. So the average woman has a pregnancy of 266 days. And we have a standard deviation of 16. We want to know what percent of women have a pregnancy that is preterm, that is 245 days or less. So if you have no more than $245 in your pocket, that means you have no more than 245, so you have $245 or less. So we are trying to find the shade. We are trying to find the probability. So it's going to be normal CDF. It began at -9999. It ended at 245. My mean is 266 and my standard deviation is 16. So these are the people, we just did the people who were way over term. Now we're doing the people who were way under term. So that means 0.0947, so 9.47% of people who are pregnant are going to deliver 245 days or less. Yay? All right, a very preterm baby is one whose gestation period is less than 224 days. Are very preterm babies unusual? Okay? So, it's going to be a similar picture to the last one. We're doing 224 or less. Is that 16? So we're going to do a norm CDF from negative 99999 to 224. My mean is 266 and my standard deviation is 16. So, I go down here for 45 minutes and I grab this last bit, cut, and I come back up here and by the magic of TV, I paste it and I get a .0043, which means 0.43, 0.5%. Now, in order to be unusual, it has to be less than 0.05, which is 5%. This is 0.5%, so it's unusual because it's less than 1%. So it's way unusual. Most people have full-term pregnancies so it's way unusual for you to have a very preterm pregnancy. All right, couple more before we start new stuff. Move this over, make it a little bit bigger. Let's just start with A. I'll come around and look. Dawn, just kidding. You did do that wrong. Yeah. You are the man. You just beat out Austin. Malika, you the woman? Now you got it. Yep. I build you up to tear you down. Perfect. Look at what you're given. Perfect. What's that number right there? You're doing it right. You typed it wrong. Good. 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 All right. And this is what's going to happen on the test, and this is what's going to happen on the homework, and this is what's going to tick you off. So, we have a normal distribution with a mean of 125 and a standard deviation of 24. He is at a 90th percentile, so what is that telling me? That's telling me the shade to the left. God is talking to us. All right, the shade to the left is 0.90. We want to know what his reading score is. We don't want to know the probability. We don't want to know the percentage. We want to know what the score is. So it doesn't say what is the percentage. We said What is the reading speed? So what are we going to be doing for this one? Inverse norm, which means we're going to do shade to the left, mean, and standard deviation. So my shade to the left is going to be 0.90, my mean is 125, and my standard deviation, but it's got to be inverse norm. And when I type that in my calculator, see how far I put this one down. I was thinking that I'm going to draw forever. There we go. It's 155.78, I think is what it ended up being. Get this with it, and I'll pull that up as well. Cut. And paste. Oops. Come on.
Okay.
155.78 or 155.8 or 156, according to how my math lab tells you to round it. All right, I think this may be the last one in this section. A school psychologist wants to determine reading rates for unusual students, both slow and fast. Determine the reading rates of the middle 95% of all 6th grade students. The mean was 125, the standard deviation was 24. You're going to do 2 separate problems. You've got 2 points that you're trying to find. You're going to do this point, and then you're going to do this point. Perfect. Okay, just making sure. That's your first point. You are the man. Okay. Look nice today. Nothing? Impress me. Anybody? Got another one? You're halfway there. Are you ready for me or not? Are we good so far? So, do we agree that the whole thing is 100% or 1? So if this is 95%, what are both of those together? 5%. And if I cut it in half, then each of these would be 2.5%. So I did 1, which is 100%, minus the 0.95, which gave me 0.05. So that meant this and this together are the 0.05. Yay? Then I divided it by 2. And that told me that this was 0.025 and this was 0.025. So together that would give me the 5%. Are we good? Yay? 95% shading plus 5% shading gives me the 100% shading. And because this is a normal distribution, that means it's symmetric like a butterfly. Which means if these together are 5%, then it's $5 cut in half, or $2.50 and $2.50. Okay? Now, it says what are the cutoff points, which means I need to know this point, which I'm going to call Z1, and I need to know this point, which I'm going to call Z2. So I've got to work out a problem to get this point, and I got to work out a problem to get this point. I've got to figure out what are those two cutoff scores. So because I'm finding the Z, that means I'm going to do what? Inverse norm. And remember, when we do inverse norm, it is the area to the left, the mean, and the standard deviation. So for Z1, what is my area to the left? 0.025, 125, and 24. So when I'm just looking at this point, my Z1, the area to the left is 0.025. My mean and my standard deviation. When I put that in my calculator, I should get that Z1 is 77.96. Is that what y'all got? Yay? Yeah. Okay? So that's my Z1. That's my cutoff point for the lower end. Now I got to do my cutoff point for the upper end. So, to remind you that inverse norm is the area to the left, the mean, and the standard deviation. So if I'm standing at Z2, my area to the left is going to be the 95% and the 2.5%. So my area, gotta find the color I haven't used. My area to the left is going to be all of that. It's going to be the 0.95 plus the 0.025, which is 0.975. And then my mean is 125 and my standard deviation is 24. And then when I type that into the calculator, I would have gotten that my Z2 is 172.04. So when I'm standing here, my area to the left. When I'm standing here, my area to the left is going to be the yellow and the blue. So it says, what are the cutoff scores? The cutoff scores are going to be both of these because you've got two different points. Cool? All right. Looks like we need a brain break before we start into Chapter 8. So let's go ahead and take our break a little bit earlier than normal. and then we'll come back and get started into 8. It's gonna be more, but it's gonna be different.